In the last video we have seen if a number is given in any base, what is the decimal equivalent of it. In this video we will see, eventually by the end of the video we will see how to convert a decimal number into any other number system. Okay, what is the equivalent number in any other base for a given decimal number. By the end of this video we will get to know that. There is a very beginner level coding problem where you have to print all the digits of a number. For example, this number 123, and this is a question that print the digits of the number. So the ones place digit is 3, tens place digit is 2, hundreds place digit is 1. So this is ones place digit, tens place digit, hundreds place digit. And how that is solved through the program, what the programmers do is this: they divide this 123 by 10. Okay, so what you get as remainder, this 3. Okay, so this is what you get as the remainder. Now what is the quotient? 12. Then you divide again, you will divide this quotient by 10 again, and what is the remainder that you get is 2. Okay, now what is the quotient? It is 1. You divide this one again by 10. This is your remainder. Go in the reverse order. This is what your numbers are. 1 2 3. 1 2 3 is your number. Okay, so at every time the remainder that you get is nothing but the digit at that place. So 3 is the digit at ones place, 2 is the digit. So 3 is the digit at ones place, 2 is the digit at tens place, and 1 is the digit at hundreds place. So this is how you solve that problem of print all the digits of it. Okay, in a similar manner you find the digits of this number in other base. Like if you want to find the binary equivalent of 123, what are you going to do? You will use this method only. Okay, but you are going to divide not by 10 but by 2. So basically, to get the digits in decimal, you are dividing it by 10. What is 10 here? 10 is the decimal base of decimal, or 10 is basically the number of symbols in decimal number system. Okay. Similarly, what is 2 here? 2 is number of symbols in binary number system. For example, this 123, you want to find the decimal the binary equivalent of it. Then you divide this 123 by 2. 122. What is the remainder? 1 is the remainder. Okay, 2 and 61, 2, 30, 1, then 2 and 30, 0, 2 and 15, 1, 2 and 7, 1, 2 and 3, 1, and 2 and 1. So you go on the reverse order, and this is nothing but your binary equivalent. So your binary equivalent is 1 1 1 1 0 1 1. Okay, and this is the binary equivalent of what? 123 in base 10. 1 2 4 8 16 32 64. So if you expand it, this is 64 plus 32 plus 16 plus 8 plus 2 plus 1. 96, 112, 120, 122, 123. Okay. Let's take another example. Convert 327 decimal into binary. So how you will do? This is 327, 2 into 1, 6, 163. What is the remainder? 1. 281. Remainder is 1. 2 into 40. Remainder is 1. 2 into 20. Remainder is 0. 2 into 10. Remainder is 0. 2 into 5. Remainder is 0. 2 into 2. Remainder is 1. 2 into 1. Remainder is 0. 2 into 0. Remainder is 1. So going in the reverse order will give you the binary equivalent. So what is the binary equivalent? The binary, so 327 base 10. The binary equivalent is 1010 00111. This is supposed to be the binary equivalent. Whatever, just expand it to get the bits of it. So this position will have 0. Okay, this is 2, this is 4, 8, 16, 32, 64, 128, 256. So when you expand it, you will get 256 plus 64 plus, कर ले तो कॉपी के साथ, 256 plus 64 plus 4 plus 2 plus 1. This is equal to 68, 70, 71. 256 plus 71. 6 plus 1, 7, 7 plus 5, 2, 1, 327. Okay. In a similar manner, you can find the octal of it. Like if you want to find what is the octal number for 327, then this will be like 327. You divide it by now 8 only. Given a decimal number in whatever base you want the equivalent number of it, you divide it by that base only, by the number of symbols in that base. So in octal there are 8 symbols. So you divide 327 by 8. 8 into 40. Remainder is 7. 8 into 5, 40. Remainder is 0. 8 into 0. Remainder is 5. So this is your decimal octal equivalent. So what is 327 in decimal is 507 in octal. Similarly, if you want to get what is 327 in hexadecimal, so 16 into 20, 7, 16 into 1, 4, 16 into 0, 1. So what is 327 in decimal is what is 147 in octal. So wait at the first position, it is 1, this is 8 and this is 64. So when you expand 507, what you will get? 64 into 5 plus 7 into 1. So this is 5 for the 22, 5 6 the 32, 32 plus 7, which is nothing but 327. Okay. Similarly, when you expand this 147, you should get 327. So this is going to be 1 into 16 to the power 2 plus 4 into 16 to the power 1 plus 7 into 16 to the power 0. 16 square 256 plus 64 plus 7. 56 plus 64. 320 plus 7, which is equal to 327. So this is how you can find a number in any base given a decimal number. Let's say a octal number is given and you want to find the hexadecimal equivalent of it, how you can do it? Very simple. You first convert that octal number into its decimal equivalent, and from the decimal equivalent you will get the hexadecimal equivalent. Okay, so for example, in this case, you know that 507 in base 8 is equivalent to 147 in base 16. 147 in base 16. Okay, now if the question originally is that you have 507, if the original question was that what is the hexadecimal equivalent of 507, okay, so how you will solve it? You will first find out the decimal equivalent of 507, and then from that decimal equivalent you will find out the hexadecimal equivalent. So decimal equivalent of 507 is what? It is 5 into 64, because this is 8 power 2, this is 8 power 1, this is 8 power 0. So 5 into 64 plus 0 into 8 plus 7 into 1, which is equal to nothing but 5 4 20, 5 6 30 into 32 plus 7, which is equal to 327. So this is 327 base 10. What is the hexadecimal equivalent? For hexadecimal equivalent, you are going to now do this. 16 into 20, this is 7, 16 into 1, 16, this is 4, and then 16 into 0, this is 1. So 147 is the hexadecimal equivalent. As you can see in the last page only we did it. So now for a given number in any base, you know how to get the decimal equivalent of it. For a given decimal number, you know how to get the equivalent number in any other base. And for any given base, okay, and the number in any base, you know how to get the number in any other base, okay, with decimal through decimal equivalent only. But you know, for a given number in any base, you know how to get the equivalent number in another base. Okay, that's okay. Now the only thing that I want to skip, that how this repeated subtraction or repeated division, how the remainders is giving you the digits. This is with little brain activity, you can do it yourself. Okay, thank you very much.